Hello and welcome. We are going to do 13.3 day 2. And I know you guys are so excited that you still get to do math even when I'm not here. So you are welcome for that. Yesterday I told you we're going to talk about something called a derivative. So this is where we're going to get into the derivatives, and I have a surprise. You've actually already done them, you just don't know it yet. So by the end of today, you're going to be able to find the derivatives of functions at a point. Now, the definition for a derivative, the derivative of a function f at a number a, denoted by, you have an f and then this looks like a apostrophe here, a, okay, is given by this following equation. So this equation should look familiar to you. Does it? Yep, that is the equation that we used yesterday to find the slope of a tangent line. Okay, so the denotation for the derivative is given by f and then that apostrophe a. So we would read this as the derivative of f at a. Okay, so this is the same formula of what we used yesterday to find the slope of the tangent line, and we're also going to use that today. Now remember, yesterday we also talked about how we could use the limit as x approaches a of f of x minus f of a over x minus a, and that would give us the slope as well. For the first few, we are going to use this equation as h goes to 0, and then for a couple of them, we're actually going to use both. And we talked a little bit about yesterday some benefits of using each. Do you guys remember what the benefit of using this was? I know we talked about it explicitly in my 6 hour. You can use this with any situation and you'll be able to get a correct answer from it. With some of the ones where you're using the f of x minus the f of a on top, you might get some kind of polynomial that you can't factor, and that's where you would run into a problem. So the first thing we're going to do is find the derivative of a function. I'm going to try to keep these notes moving as quick as possible so you do have time to practice and get your homework done, and then you could also update your homework log if you are all done with all of your homeworks. So let's look at a. So f of x equals 8x squared plus 2x minus 4 at 2. So yesterday we were given a point, and then that point was a and then f of a. Today we're only given this value, so that's what's going to make what we did yesterday different from today. So to find the derivative at 2, what we're going to do is we're finding the slope of the tangent line at the x value 2. So this is going to be our notation. Okay, so we're finding the derivative of f at 2, and then it's the limit as h approaches 0, f of 2 plus h, and then remember that comes from our original equation, which is f of a plus h. So instead of a, we're substituting 2 for a. All right, and then the plus h stays the same, and then this is minus f of 2. Remember yesterday when we had the f of a, because we had the point, we already knew what the output was, so we didn't have to do this next step. But ask yourself, okay, how do I find f of 2? Well, all you have to do is replace 2 in your f of x equation with x. Okay, so I'm going to show you that in the next step. And if you want to start working ahead, that's perfectly fine. If I'm going too fast for all of you and you need to pause the video at a certain point, you can. It's just really important that you pay attention. And then if you don't happen to get everything written down, once you're done with the video, you could go back and watch it on your own personal device with your headphones. Okay, so let's look at what happens when we substitute in the 2 plus h into our original equation. So I have 8 times 2 plus h squared plus the 2 times 2 plus h, so we're replacing x with 2 plus h, minus 4. And then I put a minus here, and if I'm finding f of 2, I'm substituting 2 in for x. So 2 squared times 8 plus 2 times 2 minus 4. I just wrote all of that out here. So really, you could do this part in your head, right? 2 squared is what? 4. 4 times 8, 32. 32 plus 4, 36. 36 minus 4, 32. Okay, so that's all I did from here to here. I just simplified this. This was 32. Okay? Now, with this part, I have to do the 2 plus h squared. Remember, if it's squared, you're going to have to FOIL. So if you FOIL, 2 times 2 is going to be 4. 2h and 2h will be 4h plus h squared. Distribute the 2 here to simplify. Okay, and then we're going to continue to simplify here. So we're going to distribute the 8. When you distribute the 8, you'll get 32 plus 32h plus 8h squared plus 32, plus 2h minus 32 over h. So now we want to clean that up. So we're going to get all of our like terms together. Go ahead and do that. And then let's see how we did. Okay, so the limit as h approaches 0 is going to be 8h squared plus 34h over h. Now remember, I said yesterday what you should see happen is you should see all of the numbers should add up to 0. Now if you just say that they add up to 0, you just drop the numbers without checking to make sure they really do add up to 0. If you do that on your test or your quiz, remember you lose points because that's not mathematically correct. Once you see that you can factor out the h, go ahead and do that. And then in the next step, you're going to write out what that simplification is. Also remember, I keep reminding you, you have to write out your limits for each step until you actually take the limit. Okay, so that's something else you have to make sure that you do on your quest, which is next Wednesday. Okay, so now when you reach a point where you can plug in 0 and you don't get anything that's undefined, you can do that and then you'll end up with 34. So the derivative of the function at 2 is 34, which remember is also going to represent the slope of that tangent line. So really, when we say derivative, what we're doing is we're finding the slope of the tangent line at that given value. All right, so now we're going to do the same thing with part B. Okay, so for part B, you're given f of x equals x over x plus 1 at 1. So when it says at 1, that means your a value is going to equal 1. All right, so now again, we're going to use the limit as h goes to 0. And then so right away, I'm going to substitute in, and let me see how I write that. So I have my derivative notation. It's the limit as h approaches 0, f of a, so my a is 1, 1 plus h, minus f of 1. Okay? Now, like I said before, if you just want to substitute 1 in and then write that value down, that's fine, because f of 1 is the output when you plug in 1. If you plug in 1, you're going to have 1 over 1 plus 1, which is what? 1/2. I hope you said it. Okay, so we're just going to have minus the 1/2. Okay, so if you guys just want to do that right away, go ahead and do so. All right, and then we're going to clean this up. So when I plugged in 1 plus h, okay, I had x over x plus 1. So instead of x, I have 1 plus h, and then it's x plus 1, so 1 plus h plus 1. So I'm going to clean that up. And like I said, if you want to write that as 1 over 2 right away, please go ahead. All right, so, sorry, I don't want to show you too much. All right, so now we're going to do the limit as h approaches 0. And on the top, I just went ahead and rewrote that in standard form as h plus 1, and then over h plus 2 minus 1/2. And then we have to think about what we did yesterday. So remember when we had a fraction yesterday? We talked about you could multiply by something. We multiplied by the denominator. Well, look, now I have two fractions, so I have two denominators. So when I multiply, I want to multiply the top and the bottom of the fraction by the LCD. So the LCD of 2 and h plus 2 is 2 times h plus 2. Okay, so those two denominators together. Now remember yesterday, we had to do what with this value when you have two terms? You have to distribute. Okay, so when you distribute, I'm actually going to write that part out for you for what it's going to look like, because sometimes if I skip to this step and go right to what it's going to look like afterwards, people freak out. So we don't want that to happen, okay? Oh, good goodness. All right, so for this, you have the multiplication by the LCD, so I'm going to write that out, what that's going to look like. So this will be the limit as h goes to 0 of h plus 1 over h plus 2, and remember that's being multiplied by 2 times h plus 2, and then it's minus 1/2, and that is being multiplied by 2 times h plus 2. So that's on the top, okay? So that's being distributed to both values on the top. And then on the bottom, be careful, because if I forget anything, it's usually I forget to multiply those together on the bottom. So h times 2 times h plus 2, so we're just going to write it as 2h times h plus 2. And remember, we want to keep it like that because we're probably going to have some cancellations. In fact, if you look here, the h plus 2 and the h plus 2 are going to cancel out. The 2 here and the 2 here are going to cancel out. So then let's clean that up. Okay, so then this will be the limit as h goes to 0. Now I just have 2 times h plus 1. You can either distribute it here, or if you want to write it as 2 times h plus 1 to remember, that's fine too. I'm going to do 2 times h, which is 2h, 2 times 1, which is 2. And then here I have a negative 1. So I'm multiplying negative 1 by h plus 2. So this would be negative h minus 2. So this is another common thing people forget. They forget to distribute when you have a negative, or even sometimes just when you have two terms. Okay, so if you want to write it out this way, you absolutely could do that. Sometimes as you get better at this, what you'll realize is, okay, if you're multiplying by the LCD, you know that h plus 2 and 2 are going to cancel out, so you're going to be left with 2 times h plus 1. For the second one, the 2 and the 2 are going to cancel out, so you're going to be left with negative 1 times h plus 2. So if you didn't want to write out the distribution, you could go right to that step, and we'd still be here. Okay? You'd still get the same top value. This would still be h times 2 times h plus 2, and then we'd still want to clean that up. Oh, I'm showing you too much. Sorry. I don't want you to get overwhelmed. Okay, so you guys said too late, didn't you? I bet you did. All right, so now what we're going to do is we're going to clean that up. So the limit as h goes to 0. So 2h minus h is what? H. Yes, 2 minus 2 is 0. Okay, on the bottom, we're going to keep it as 2h over h plus 2. Notice the h's are going to cancel out. So limit as h goes to 0. This now becomes 1 over 2 times h plus 2. So now ask yourself, if you were to substitute in 0 for h, would you be able to find a valid answer? And of course, the answer now is yes, that would definitely happen. So we'd have 1 over 2, and then 0 plus 2. So 1 over 2 times 2, which would be 4. Okay, so then our derivative is going to be 1/4. So the derivative of f of x at 1 is going to be 1/4. All right, let's flip it over. Let's keep it moving. So on the back page, it says that we're going to find f of a where a is in the domain of f. So I like this because it's all algebra, but that means you aren't going to be plugging in any numbers, so you're going to be dealing with expressions. Okay, so if you're going to find f of a where a is in the domain of f, remember we talked about this the other day. If it's in the domain, what does that mean? Okay, if a is in the domain, then that means you will get a solution. I should say a real solution, aka otherwise known as it's not undefined. And since we are dealing with arbitrary values, okay, we are just going to say that a is in the domain. So if you're looking at part A, f of x is the square root of 7 times x. The domain for that, do you guys remember how to find it? It's a square root. You can't take the square root of what? Negative numbers. So all your values, 7x, would have to be greater than or equal to 0. Divide by 7. So your domain for this is all values of x such that x is greater than or equal to 0. Okay, so we don't have to find those. We just know whatever our final expression is, that it's only going to be true for values that are greater than or equal to 0. Okay, so for this, you can use either equation, and like I said, I'm going to show you both ways. So the first way is going to be your derivative of f of a equals the limit as h approaches 0, and that's of f of a plus h minus f of a over h. Okay, so now what we're going to do is substitute our values in. So we're going to do the limit as h goes to 0. F of a plus h means I'm plugging in a plus h in for x. So this is going to be the square root of 7 times a plus h, 7 times x, minus f of a. So if you're just substituting a for x, you're just going to have the square root of 7a. And then, of course, this is all going to be over h. Now, remember when we have the square roots, what we want to do is we want to rationalize them. So we're going to do that in the next step, and then I'm also going to simplify this, which would be the 7a plus 7h. And we're going to do that now. So this would be the square root of 7a plus 7h minus the square root of 7a over h. And then we're going to multiply by the conjugate of this value. So the conjugate would be the square root of 7a plus 7h plus the square root of 7a over that same value. And when you're doing this on your homework, I don't mind if you do the quotes there, but on your test or quiz, you need to write it out. And if you do put the quotes, that's really an easy way to forget what you need to multiply on the bottom. So when you're rationalizing, when you're multiplying those together, we still have our limit as h goes to 0. So the square root of 7a plus 7h multiplied by itself is 7a plus 7h. And then the negative square root of 7a times the positive square root of 7a is minus 7a. this is another part where people forget you do have to distribute if there's more than one term. 7a is just one term, so luckily we don't have to worry about that yet. And then the denominator is h multiplied by this value. Okay, so don't forget that this part is still in the denominator. Okay, so now we can clean this up. See what happens? We have 7a minus 7a. So we're just going to have the limit as h goes to 0 of 7h on the top. So then what's going to happen next? That's right, your h's are going to cancel out. Okay, so once your h's cancel out, you can go ahead and, actually, I just wanted to see if I want to go to the top. No, I'll just keep going here. Okay, so this will be the limit as h goes to 0. So 7 over, our h's cancel. So I have the square root of 7a plus 7h plus the square root of 7a. Okay, and then we do want to check and we do want to see if we can substitute in 0 for h for this point. Okay, so if you plugged in 0 for h, you'd have 7 on top, and this is the square root of 7a plus, what's 7 times 0 going to be? Yeah, it's just going to be 0. So you can actually just leave it as the square root of 7a and then plus the square root of 7a. Now these two are the same. So because those two are the same, your final answer is going to be 7 over 2 square root of 7a. These are like terms. They have the same radical. So the coefficients, 1 plus 1, will give you this, and that will be your final answer. So this is different from yesterday because we had a number. Now that we're just doing f of a, you're going to have an expression. Okay, so now we're going to do the same thing, but we're going to do it with the other equation. And then the final one, we'll actually just do that with the other equation. And then if you wanted to do it with the other one, you could. Okay, so let's say I want to find the derivative of f of a, but now I want to use the limit as x goes to a, f of x minus f of a over x minus a. Okay, so then what I'm going to do is I'm going to find my f of x and then my f of a. So the limit as x goes to a, so a is just any value, f of x is still the square root of 7x. F of a would be the square root of 7a over x minus a. Okay, now you can't just factor out the square root of 7 here because the x is inside the radical. So what we need to do is rationalize. So same thing as before, we're going to multiply the top and the bottom by the conjugate so that we can rationalize. Okay, so then on the top, the square root of 7x times the square root of 7x is going to be 7x. The middle will cancel out because they're opposite, and then negative 7a times positive 7a is going to be negative 7a, and that will be over x minus a. Okay, and then can you guys see what you can do in this step? I actually kind of showed it to you yesterday. So this is the limit as x goes to a. You can factor out a 7. So if you factor out a 7, you have 7 times x minus a over x minus a. Okay, and remember, don't skip your steps. So you're going to have to show me that this is where they cancel out. And, oh, what did I forget? What do I need in the denominator? I told you I forget that step sometimes. Can't do that. All right, so x minus a is multiplied by the square root of 7x plus the square root of 7a. And I caught myself right away because if you were to cross those out, you'd just be left with 7. Well, that's not our limit. We know this should be our limit. So this is multiplied by the square root of 7x plus the square root of 7a. Right, so now these are going to cancel out, and your limit as x goes to a is 7 over the square root of 7x plus the square root of 7a. Now before, when we did this, we had the h goes to 0, and we said, okay, we can plug in 0 now. We can plug in 0 for h, and then all we were left with are a's. For this, see how the limit is as x goes to a? That means we can plug in a for x. So this would be the step where we would do that. So now we can plug in a for x, so this would be 7a plus the square root of 7a, and then this is just like our final step of the last one. All right, and then we should get the same thing, which we did. All right, now you guys can think about what you like better. And like I said, for this one, we are going to do that second equation as x goes to a. If you want to do the other one after this one, you are welcome to do that. So the limit as x approaches a, or if you've already done this and you're waiting for your homework, then yes, you need to do the other one. So we're going to have the limit as x goes to a, and then it's f of x minus f of a over x minus a. So when you're doing f of x, that's just going to be your given equation. Okay, so your given equation, I think I keep saying okay a lot. I apologize if that's the case. Okay, just kidding. All right, so the limit as x goes to a, f of x is going to be x over x plus 1 minus f of a, which is a over a plus 1. And then all of that is over x minus a. Okay, so some of you might be thinking, oh, well, at the very end of the last one, we just plugged in a for x, so I should just do that now and then forget about it. Well, no. Once you plug that in, your limit goes away. And you can't just plug in a here because then the denominator would be what? Yeah, 0. So then it'd be undefined. So again, when you have a fraction, what do you need to multiply by? You are going to multiply by the denominator, but if you have two fractions, you have to multiply by what? The LCD. Okay, so the LCD of these two fractions is going to be x plus 1 times a plus 1 over x plus 1 times a plus 1. Okay, so multiply by the LCD, the lowest common denominator. So like I said, if you guys want to write this out, you are welcome to do that. If you know what's going to cancel out and you just want to write the next simplified step, that would be perfectly fine. Okay, so I'll show you. If you have the limit as x goes to a, if you want to write both of those next to it so you can see the cancel out, that's fine. It's x plus 1 times a plus 1 minus a over a plus 1 times x plus 1 times a plus 1, and that's all over x minus a times x plus 1 times a plus 1. Okay, so you're welcome to write all that out, or if you can see that when you multiply, these are going to cancel, and you just want to write down x times a plus 1, you can go ahead and do that. So you'll either show this step where they cancel, or you'll just write x times a plus 1 minus, and then again, you can either show they cancel or just write negative a times x plus 1. Okay, so then this is the limit as x goes to a. So I'm left with x times a plus 1, which I'm going to distribute. X times a is ax. You can write it as xa, but I always write it in numerical order. Okay, so x times a is ax, x times 1 is going to be x. Now this is a negative, so make sure that you take that with it. So negative a times x is negative ax. Negative a times 1 is going to be negative a. All of that's over x minus a times x plus 1 times a plus 1. And then we're going to clean this up. And like I said, derivative is a term that you're going to see a lot in calculus, so you are going to end up doing some of this next year. So before you can use all the fun rules, you're going to do it by hand. Alright, so ax minus ax is going to be 0, so I'm left with x minus a. I can see now that those are going to cancel, so I'm going to do the limit as x approaches a of 1 over x plus 1 times a plus 1. So at this point, now because this canceled out, what I can do is I can plug in a, and I won't get 0 in the denominator. So once I do that, that's when I can drop my limit. Do not do it before then. So this is a plus 1 times a plus 1. Okay, so you can write your final answer as 1 over a plus 1 squared. And that will be your final value. Alright, so now the rest of the time you can use to work on your homework. So this is 13.3, day 2, and this is page 863. Numbers 15 through 22. Okay, and if you have not checked your other homeworks, when you're done with this, you can go ahead and update your homework log. We are turning that in the day after your quiz, and we already talked about the front side. The back side should be 13.1 day 1, 13.1 day 2, 13.2, 13.1 day 1, 13.3 day 1, and 13.3 day 2. Okay, so you have 13.1, 13.1, 13.2, and then 13.3, 13.3. Okay, I will see you guys on Monday for the review. Have a good weekend.